All right, quiz tomorrow. You're going to have two graphing. One graphing exponentials, one graphing logs. You're going to have 2 or 3 of those one-to-one properties. Then the second part is going to be the calculator with the interest stuff. All right, I told you guys last week, these are the basic similarities and differences between exponentials and logs. Remember, exponentials and logs are inverses of each other. So in an exponential function, the domain is always negative infinity to positive infinity. You're going to have a horizontal asymptote. You will not have a vertical one. Your range is based upon your horizontal asymptote, right? It's always y equals. Don't just write a number. I'm not going to give you full credit for it. There is not a vertical asymptote. And to find the y-intercept, you plug in 0 for x. We write it as an ordered pair, right? This needs to be written as an ordered pair. Don't forget that. And then our logs are the inverses of that. So instead of the domain being negative infinity, positive infinity, it's the range. You have a vertical asymptote, not a horizontal one. Your vertical asymptote is x equals. The way that you find that is you set the parenthesis equal to 0. And then we're going to find an x-intercept where you plug in 0 for y. Now, on these, I'm going to go through all of these. On these first two, right, I am not asking you to identify the transformations on the quiz. It's just good for you to know what everything does inside the equation so you can kind of get an idea of what your function looks like. When I look at number 1, my base is a whole number 2, which tells me it's a what? A growth, okay? I know this is a growth based upon the base. So in my mind, I'm like, okay, it would usually look like that. But there's a lot of transformations that are going on inside of my equation. What does this negative out in front mean? It's going to reflect over the x. So instead of it actually going upwards like this, it's actually going to go like this. What does this plus 6 right here mean? Where does it move? Left 6, good. This is over x. And what does that minus 1 mean? Down 1. Now, again, I am not asking you to identify those tomorrow. But it's good to kind of have an idea of what your graph should look like. So when you do plug in points and you give me values, you know that you're on the right track, or you're not like, wait a second, I must have done something wrong with my math. So I will have lines for you to write the domain, the range, exactly what I'm looking for. You guys will have on your paper. Horizontal asymptote, vertical asymptote, and y-intercept, right? Those are all things we need. What do I know right away? There's 2 things I can say right away. The domain is what? Negative infinity to positive infinity. Good. What else do I know? There is no vertical asymptote. There's none. So how do I find the horizontal asymptote? The vertical shift. Where is my horizontal asymptote, guys? At y equals negative 1. So I know my range is either going to be negative infinity to negative 1 or negative 1 to infinity. You should be able to tell me that right now. If you can't, that's okay. You'll be able to once we graph it. Let's find our y-intercept. How would you find the y-intercept? Plug in 0 for x, okay? You guys are going to have to do a little bit of math here. So I have 2, what is it, 0 plus 6? Minus 1, okay? What is 0 plus 6? 6. Guys, what do we do first? Is it negative 2 to the 6th power, or is it 2 to the 6th power, and then a negative goes in front of it? It's 2 to the 6th power, which is what? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. What's 32 times 2? 64. So this is negative 64 minus 1. So what is your y-intercept? At 0, comma, negative 65. Am I going to expect you to put 0, negative 65 exactly on the graph? No, but we need the general area. So now I need some other points. I need to know what my graph is going to look like. I'm going to need some other points. I know that I have a horizontal asymptote right here at y equals negative 1, right? And I know that my y-intercept is way down here at 0, negative 65, right? Some sort of an idea. So let's plug in -1 and +1 and see what we get. If I plug in -1, I'll do it up here. I have -2 to the -1 plus 6 minus 1. What's -1 plus 6? 5. So what's 2 to the 5th power? 32. So this is -32 minus 1, which is what? -33. So if I had an XY chart, when I plugged in -1, I get -33. When I plugged in 0, I got -65, right? And then when I plug in +1, what happens here when I plug in +1? I have -2, to the 1 plus 6 minus 1. Well, what's 1 plus 6? 7. So 2 to the 7th power. Well, 2 to the 6th power was 128. No, it wasn't. 64. What's 2 to the 7th power? 128. So -128 minus 1 gives me -129. So guys, what is this showing you? Right, here's -1. I'm at like -33, say. Here's +1. I'm down here at -129. Do you see the general shape of your function? Yes or no? Yes or no? Okay. Does this graph have an x-intercept? No. It's going to get really, really close to y equals -1, but not touch it. So what is your range from where to where? -infinity to where? To -1. You guys could have told me that right here. Because what did this tell you the function was going to do? Flip over the what? X-axis. It's either -infinity to the asymptote or from the asymptote to the infinity. If you have a positive exponential function, your range is going to go asymptote to infinity. If you have a negative out in front, it's going to be -infinity to the asymptote. But again, if you don't remember that, if that doesn't resonate in your brain or anything like that, graph it. You guys have to graph. You have to give me at least 3 points. The y-intercept and then 2 more. You can't just draw a willy-nilly graph. I have to see at least 3 points. Everybody understand that? It'll say it in the directions. So look at number 2. Just looking at this, what is 2/3? Is it a growth or a decay? It's a decay, okay. What does this negative sign out in front here mean? It's going to flip over y, okay. So in your mind, you should be like, okay, over y. What does that +1 do? It goes left 1. What is this whole number 2 in the exponent? Tell me. It's a horizontal what? Shrink. Very good. And what does the 1/3 out in front mean? It's a vertical what?
Wait, which one's the shrink? The -2?
No, the negative is over y. The whole number 2 is the shrink. Mm-hmm. What about the 1/3? What's that 1/3 out in front mean? It's a vertical shrink. Good. Okay, again, if you guys don't know what all of those things do, that's okay. This is just very helpful information when you graph to know if you're on the right track or not. But for your domain, your range, you have horizontal asymptote, you have a vertical asymptote, and we're going to find the y-intercept, and then we're going to graph it. What do you know right away? I know my domain is -infinity to +infinity, right? What else do I know there's none of? There's no vertical asymptote. How do I find the horizontal asymptote? The vertical shift. What am I adding or subtracting to this function? Nothing. So what's my horizontal asymptote? Y equals 0. It's not nothing, guys. If there's nothing being added or subtracted, it's y equals 0. So now let's find our y-intercept, okay? So I have to plug in 0 for x. You guys are like, oh, geez, I can't believe she gave us fractions. You're probably going to have fractions tomorrow, but watch how easy we can all do this. What's -2 times 0? 0. So this is just really 1/3 times 2/3, right? Because it's 2/3 to the first power. Guys, this does not equal 3/3. What is 1 times 2? 2. What's 3 times 3? 9. So your intercept is at 0, 2/9. Has to be written as an ordered pair. Has to be written as an ordered pair. So let's kind of give an idea of what we're looking at. I know that you said that my asymptote was at 0, right? And I know that if this is 1, my intercept is going to be like here-ish. Right? In between 0 and 1. God bless you. So let's plug in -1 and +1 and just see. Guys, right now you can tell me where the range is. How do you know what the range is? Where does this graph cross the y-axis? Above or below the asymptote? Above. So is your graph going to exist down here? No, because it's going to go through that intercept, but it's not going to touch your horizontal. So you can already tell me what the range is. But if, again, you don't see it yet, no big deal. Let's plug in -1 and +1. So I have 1/3, 2/3 to the -2 times -1 plus 1. What's -2 times -1? 2, and 2 plus 1 is what? So I have 1/3. What happens here at that 3? What does that 3 do? I'm going to distribute it to the top and bottom, right? So this is 1/3 times, what's 2 cubed? 8, good. And then what's 3 cubed? 27, perfect. So I multiply across, I get 8 over what? 8 over 81. Okay, so you guys are like, what? 8 over 81, I don't know where that is. What do you know that number is? Greater than or and less than? It's bigger than what? It's bigger than 0, but it's less than what? 1. So say it's like there-ish. Okay, again, doesn't have to be perfect. Got to be in the right vicinity. So now when I plug in +1, I have 1/3, and then I have 2/3 to the -2 times 1 plus 1. Well, what's -2 times 1? -2. And then what's -2 plus 1? So I have 1/3 to the 2/3 to the -1st power. Would you guys agree that I could write it like this? 1/3 and then 3 over 2? How'd I just do that? How'd I go from 2/3 to the -1st power to 3 over 2? When you distribute the negative, right, you get -2 to the -1st over 3 to the -1st. In order to make exponents positive, you move them. So guys, this just becomes 1/2. So when I plug in 1, I get 1/2. Again, do we know about where 1/2 is on a graph? Yeah, it's in between 0 and 1. But do you notice the shape? Do you notice the direction of this function? What is the range? Where does this function exist? From where to where? From 0 to positive infinity. You guys can tell the range once you have the asymptote by negative signs. If your exponential function is negative out in front, your range is going to be -infinity to the asymptote. If it's a positive function out in front, it's going to be from the asymptote to infinity. But again, if you don't see that, plot points, you guys will get the general direction of what your graph will do. Does that make sense? You guys have to do one of those by hand. You're also going to have to do a log by hand. All this first stuff that we're doing now, you're doing by hand. Logs are a little easier because you guys don't know yet really how to solve for the x-intercept and stuff like that. So when we're talking about logs, again, you're going to have the domain, range, vertical asymptote, horizontal asymptote, and this time we're going to find the x-intercept. 2 things I know right away. What do I know right away for a log? The range, good, is -infinity to positive infinity. It's the opposite of our exponentials. And what else do we know? There's no horizontal asymptote. Perfect. Domain and vertical asymptote go hand in hand. How do I find the vertical asymptote? Parentheses equal to 0. Everybody agree with me on that? Okay, so x is -1/4. So let's talk about our graph for a second. All right, you're going to have to graph this. You guys do not have to have a table of values for this one because you don't know how to do that yet. So here's -1, here's +1. I wrote a 0. Here's +1. My asymptote is at -1/4. It's to the left side of 0, right? Now, you guys can tell me what the domain is. You may not see it right away. That's okay. If you don't see it right away, just find the x-intercept. How do we find the x-intercept? Plug in 0 for what? For y. So 0 equals log 4 of 4x plus 1. Guys, what did we talk about last week? Exponentials and logs are inverses of each other, right? So how do I get that log base 4 to go away? I put a big base 4 and everything goes up good into the exponent. What you do to one side, you do where? So this becomes big 4 to the 0 power, right? So if we simplify this, 4 to the 0 power is 1. What happens with 4 log 4? It cancels. Perfect. Every time that'll work out so you have a nice, pretty equation to solve. Do you guys agree with me? I'm going to subtract 1 from both sides. I get 0 equals 4x. So divide both sides by 4. What does x equal? So I write my intercept as an ordered pair. My x-intercept is at 0, 0. Here is my x-intercept. Which side of the graph does my function exist? On the right-hand side of the asymptote or the left? On the right, because it's not going to touch your asymptote, but it's going to go through the intercept. So just hug your asymptote and make a right-hand turn. So what is your domain? -1/4 to what? To infinity. Perfect. Does not include because it doesn't touch the asymptote. Very good. All right, this log is the exact same thing. We're going to do the exact same thing. Domain, range, vertical asymptote, horizontal asymptote, x-intercept. What do I know? Straight away, what do I know? Is good, -infinity, +infinity. What else do I know? There's no horizontal. Good. How do I find the vertical asymptote? Set the parenthesis equal to 0. Agreed? Okay. So x equals 7/2. Now, you should be able to tell me the domain right now, but if you don't see it, no biggie. 1, 2, 3. 1, 2, 3, 4. Where is 7/2?
How can you tell the domain?
I'll tell you in 1 sec. I'll show you. I'll point it out to you. Where is 7/2? It's in between 3 and 4. So it's here-ish. Now, Mikey just asked a good question. How can you tell? How do you already know? I'll show you in a second. If it's not jumping out at you, no biggie. Let's find the x-intercept. So I plug in 0 for y. So 0 equals log 2 of -2x plus 7. All right, what's the opposite of log base 2? A big 2, right? So then everything goes in the exponent. What you do to one side, you do where? To the other. So 2 to the 0 power gives me 1. 2 log 2 cancels out. I have -2x plus 7. You guys agree with me? We're going to subtract 7. So -6 equals -2x. Divide both sides by -2, and x equals 3. So my intercept is at 3, 0. So my intercept is here. Guys, where does my graph exist on this one? On the left-hand side. So to draw it, just hug the asymptote, make a left-hand turn. So what's my domain here? Huh?
Is it 3 or negative?
It's -infinity, good, to what? To 3. So do you see that the number 3 was asymptote to infinity, right? Oh, I'm sorry, it's to 7/2. It's to the vertical asymptote. Does anybody see a difference in the equations? Yes, ma'am.
In one of them, your x is positive,
Do you see here how the inside here is positive? What's going on over here? It's negative. When it's a negative inside with the x, what does it reflect over? The y. So just like on the top here, if you had a negative, it flips over the x. If you have a negative inside, it flips over the y. It moves it from the left-hand side to the right-hand side. But again, if you didn't see that, that's okay, because you would find the vertical asymptote algebraically, then you would find the intercept, and you'd see, oh, it's on the left-hand side of the asymptote versus the right-hand side. Does that make sense? That's why it's good to just know what those negatives do. So in your mind, you can kind of be like, oh, okay, all right, this is what this does, this is what that does. Questions on those ones? You're going to, yes? Go ahead. Your guys will have one of each of those. Every version of the quiz will have one of each. You'll have an exponential and a log. Then you're going to have a couple that are the one-to-one property. If I tell you to solve using one-to-one, what does that mean? You can get the bases the same if they aren't already the same. If you look at number 5, these bases are already the same. So what can I do once the bases are the same? You just cross them off. So this becomes x plus 3 equals negative 6x minus 3. Move x's to one side, numbers to the other. So I'm going to add 6x. You guys agree? Add 6x minus 3 from both sides. So 1x and 6x is 7x. My 3's cancel. Over here, my 6x's cancel, and I have negative 6. Divide both sides by 7, and what do you get? X equals negative 6 over 7. What can you do with that number to check your answer? You can plug it back in. I mean, are you going to have to get a common denominator? Yeah, no big deal. But you can take this x value and plug it in right there and plug it in right there. And the left-hand side should equal the right-hand side to check it. Okay, so if I look at number 6, it says solve using one-to-one. That means, okay, the bases may not be the same right now, but I can get them to be. Can I rewrite 9 and 27 to have the same base? Yeah, what can I rewrite 9 as? 3 squared, right? That's the same as 9. And then I still have that 2x in my exponent. I did not change the value there. I just changed the way that they look. So on the right-hand side, 27. How can I rewrite 27? 3 cubed. 3 to the third power. Okay, that's the same thing. And then I still have my 2x minus 4. Now that the bases are the same, guys, what can we do? You cross them off. And then you just solve. 2 times 2x is 4x. 3 times 2 is going to give me 6x minus 12, right? Now if we simplify, we subtract 6x from both sides. So negative 2x equals negative 12. What does x equal? X equals 6. So, you go ahead, you make a silly mistake. You say, oh, negative 6, because you missed a negative sign. If you plug it back in, what should happen? The left-hand side should equal the right-hand side. So if you make a mistake with a sign or something, you should check it, and then you'll be able to find your mistake. This one. Oh, gosh, we have fractions. Every time we see fractions, we freak out, right? How did I tell you to rewrite fractions with whole number bases? This is 4 to the first power in the denominator. How could I make that a whole number? I'd move it up. If I move it up to the top, to the numerator, what happens to that 1? It becomes negative. I could rewrite this as 4 to the negative 1. That's the same as 1/4. And then I still have that x there. It didn't go anywhere. And I have 8 to the negative 3x plus 2. Now that I have whole numbers, these are it's easier to look at. How can I rewrite 4 and 8 so they have the same basis? 2, good. 2 squared, right, is the same as 4. And then I still have that negative x, negative 1 times x. Then over here, Mikey said 2 cubed, agreed. 2 cubed is 8, and then I still have 3x plus 2. Now that your bases are the same, we cross them out. I have negative 2x equals negative 9x plus 6. I'm going to add 9x to both sides. I have 7x equals 6. Then do what? Divide by 7, and x equals 6/7. Well, that's an interesting coincidence. And now what can I do with this number? I can plug it back in. Is it the easiest thing in the world to plug back in? No, but you guys can do it. So that's the first part of your quiz. Part 1 is going to have solving one-to-ones, and it's going to have one exponential and one log. Guys, don't get stumped if you have something like this. That's not no solution. What does x equal here? X equals 0. Remember, anything to the 0 power equals what? 1. If you get a question like that, don't get stumped. Don't raise your hand and tell me, something's wrong. No, it's not. All right, then along, you guys will have your calculator portion. All right, I will make sure all of your calculators are cleared before you do this part. All right, it is important, guys, on this section for a couple things. Right? You have to show me work for a few reasons. One, because if there's no work, there's no credit. You guys tell me, how do I show work on a problem like this? I need to see what you put in the calculator for a couple reasons. One, to see that you know what you're doing. Two, I can give partial credit if you wrote down the whole formula correctly, but you missed a decimal. You put it in the wrong spot, something like that. Right? I have to see what you guys are doing. So remind me again, our two formulas. One formula is A equals what? P times 1 plus R over N to the what? N times T or T times N. Good. Remember, P is your principal. This is what you start off with. R is your interest rate in decimal form. N is how things are compounded, quarterly, monthly, yearly, something like that. And then T is time. When do we use that other formula? Continuous. When it says continuous, you use apert. So each one of these is very similar, but the answers are all different. Right? If I were you, I would say, okay, my principal, what did I start off with? 24,500. What is my rate? 0.027. It's 2.7%. Move that decimal 2 places to the left, you get your 0.027. What is my time that I'm using? 4. So in all three of these, 8, 9, and 10, you're using all of that information. Same thing every time. What is changing? The N value. And number 8, your N is what? What is quarterly? 4. In number 9, what is monthly? 12, good. And in 10, what does continuously mean? Apert. Really important that you guys remember that. If I said weekly, how often does something happen in a year if it's done weekly? 52. What is daily? 365, good. What is semi-annually? 2, okay? We need to know those things. So what I need to see from you in number 8, this is exactly what it should look like. It should say 24,500, parentheses, 1 plus 0.027 divided by 4, close your parenthesis, close the parenthesis, and you're going to raise it to the 4 times 4. I need to see that. Then you guys throw it in your calculator. I know on WebAssign, a lot of you are having major issues with the rounding. I get that. I will look at your work versus your score. Don't worry about it. I mean, if you didn't give me work, then I can't give you any credit for it. But I know that depending upon if you did it in steps versus sometimes you rounded in the wrong spot. But what did you guys get here? Practice doing this in your calculator. 24,500, parenthesis, 1 plus, parenthesis, 0.027 divided by 4. Close, close, raise it to the 16th power. What'd y'all get? 27,284. Yeah. And then how much change? 27 cents. Okay. Guys, look at the difference here. Look at what you started off with, 24.5. And then after the compounded, however, at this interest rate for 4 years, you got 27,284. All right, not a huge jump. You should not go from 24,000 to 1.7 times 10 to the 17th power, something like that. Check your work. This is what I need to see on your quiz. So your next problem, monthly, is going to look exactly the same, just your N value changes. So 24,500 1 plus. Still have that same interest rate of 0.027, but now I'm dividing it by 12, and then I'm raising it to the 4 times 12 power. So calculator peeps, what'd you guys get? 24,500. 1 plus, parenthesis, 0.027 divided by 12, close, and then raise it to the 4 times 12. What'd y'all get? 290 and 86 cents. Mikey, yeah? Okay. Now, if you're working on this right now and you're like, how are they getting these numbers? And you don't want to tell me, that's fine. Wait till I'm done, and then I'll help you go through it if you want me to go through it with you. But notice again, you went from 24 to start with, 24.5, to 27,290. Not a ginormous jump. When I see continuous, I need to know I have to use the APERT formula. So in continuous, we're going to have 24,500. E, and then you have to raise it to the 0.027 times 4. Some of your calculators require you to put this in parentheses. Some of them, it just moves it to the exponent for you, and then you don't have to worry about it. But just know your calculator. Tomorrow, if you come in and you don't have one, you cannot borrow someone else's once they're done. You have to have your own calculator. But what do we get in our calculators here? 27,000, how much? 294.17? Okay, perfect. Guys, remember, we're talking about money. You round to 2 decimal places. I don't need to tell you, round your answer to 2 decimal places. We're talking about money. You don't go into a bank and be like, I need 5,000.76493. No, right? When you check out at Publix, they just give you 2 decimal places for your change. Make sure you round correctly. And that, ladies and gents, is your quiz.